So, just to start with, who am I? I'm Petter. I work at a consultant firm from Stockholm called Magello. I'm a Linux and programming enthusiast. I'm an experienced and quite curious developer, I would say. I like to try everything new. And I also am somebody who has opinions about time. So, in computer systems, we often want to know something in particular. It's when. When did something happen? In a point of time, when did something happen? We can use it for comparison, like knowing something happened before or after each other. Or we need to know what it was over there, when it's over here, because we have a globe with different time zones, so sometimes we need to know when it was and try to translate it to when it was to our humans. Sometimes we also just need to know how long something is. Like, you probably know that something can feel slow and something can be fast, and it's more to that feeling thing that is the human part, like waiting for something that is exciting, takes forever, while having that fun, it's gone in an instant. So, what is the big deal with this talk? Well, this is the main crux: humans. Humans are subjective and have opinions. Humans assume a lot of things. People are stupid. Computers will do exactly what people tell them to do, but we're very bad at telling the computers what we actually want them to do. And that includes me also, so don't take any offense on that. So, I want to see some hands up and do a little query. Here's a letter on the screen. Do you know why I put it here? I see a few hands. That's pretty good, actually. Have you ever been affected by a time-based bug in your code? I'll see a lot of hands now. Yeah, that's cool. And let's go to human assumptions. So here are some things that the bug part usually can happen around. Like, a day is 24 hours long. So if you put that in your code, you will get a bug. Or a minute is 60 seconds. If you put that in your code, you will get the bug. And time can never move backwards. If you put that in your code, you get a little bug. So, and leap year is every 4th year, and there's 7 days in a week somehow, and 52 weeks in a year. Or that the day starts on a Monday, maybe a Sunday, sometimes even a Saturday. That's something called a GMT. It's something called a UTC. There's only one common letter, which is a T, so they're clearly not the same. And that your program will never run in different time zones. These are some very common human assumptions. And I would want to say that they're mostly wrong, sadly. But most of them are edge cases, and it's edge cases that created bugs that are not very easily to see. And programming time is easy, usually, you think. Even I think it's easy, and then I get told by the bug that, no, you're dumb. So, serialization. This is a huge part of this time talk. So, typically, you want to know a time and date, and the computer will know a time and date. And it looks like this. It's a number, it ticks up every second, and it doesn't really tell me much as a human. If I go to somebody on the street and be like, yeah, can you read this number, what time is it? They will say no. But this is the so-called Unix time, or epoch, which is the seconds since January 1st, 1970. UTC. And it's not non-leap seconds, but that's a different part. And this is, like we said, not very human readable, but it's what actually computers usually use. They have an integer in them, and it ticks up. And that's how the computer will keep the time. But it doesn't do much good, so we can do better. We can present it as text, at least for humans to read. So if I do just the date command in my Linux prompt, I will get this. Or I will put the RFC 5322, which is the standard how it looks for emails. Or the 3339, which is a very common standard for representing time in general, in APIs and so on. And sometimes people go and say, oh, I have heard about this ISO, because there's always enough standards in the world. We never have enough of them. And then we have the ISO as well. And these are some ways to represent time. Sadly, there's a bit too many. And when it comes to just time in general, there's something that creates accessibility in them. So to give a user a good experience, you usually don't write the clock on blog posts and when something happened. You will do this little part here, which is like, it says updated 14 hours. It's small, so I know that you are in the back, maybe don't see it. And if you mouse over, then it maybe tells the time. Please do this if you're going to do something in the web, because the mouse over actions can give a very human, readable thing, even if it's relatable, because in this image, it's a picture, so it doesn't mean anything anymore. And sometimes it doesn't help much, like this. It says, over a week ago. Over a week ago, huh? Okay, over a week ago. I guess these are two elements that are both over a week ago. The birth of the universe, which was clearly over a week ago, and last week, which was, or a day plus of last week, is over a week ago. And in this case, I could mouse over, and it's too small for you to read, but you get to trust me that this is what actually is very helpful if you ever write something, to put a title on your thing. And also you can use other things like a date format and so on to help people that actually don't read or have no sight, I mean, to have something that can help them read whatever it should be saying. For example, maybe they don't care too much about if it says over a week ago either. They maybe also want to know when was something happening. So please do this if you want to try to make your app accessible on the web. Then we come to something called localization. So many different countries will have many different standards and rules, and they get to dictate their own standards and rules sometimes. And famously, we get a small confusion on the internet for dates. So here's a date that most people can read, and everybody knows that it's the 12th of November. And the same date can be read, and you very clearly know that it's the 11th of December, or December 11th, 2025. And this happens more or less all the time on the internet, still. There's a webcomic I like, XQCD, which has a pretty old thing here. That's just trying to make a public announcement that use it in this format over here. I'm trying to use the laser pointer, but I can also do it here. And not any of the other strange formats that you can invent for yourself. Please don't. So if you're going to write something, write year, month, day. Oh no, breaking news. It has been 0 days since I saw an incorrect $datetime in an OpenAPI specification. And it didn't follow the RFC 3339. So what do I mean? Well, if you're using an OpenAPI specification, or Swagger sometimes they call it, which is the old name, and you make your string into a $datetime, then it needs to follow RFC 3339, because that's what the specification says. So if you have this part here, you need it. It's mandatory. And sometimes it just, poof, disappears. And you're probably a Java programmer or something. It's not there for some reason. I don't know why. They say that they're going to give me a datetime, but they don't. And I've seen it all the time in open APIs. And it usually creates, like, for the problem, or for the people that makes the API, it's not a problem, but for the people consuming the API, it usually creates small bugs and problems. So here's from the definition, and it clearly says, these are some reserved words. For example, the datetime. And it says here it needs to be on the specifics format, and RFC 3339 requires you to have the zone info. And it also says in the JSON schema, which is the newer from OpenAPI 3.1, they use JSON schema instead, and they also go with the same thing here. And now I did say lots of different stuff, like Zulu, offset, time zone. Well, what are they? Well, Zulu, it's the Z that you saw, and it means zero offset from the so-called UTC. What is UTC? Well, it's an offset. Or the first thing is an offset of UTC. So offset, it can be something, it's a UTC, and then you have something relating to it, either forwards or backwards. It can be hours and minutes. And a time zone, it's a set of rules for a special zone, like Europe Stockholm has a set of rules, and Europe Prague has a set of rules. So UTC, what does it even stand for? Well, we had in the past two great nations, the English and the French, and they're very good at creating standards and stuff. So the English were like, well, we're gonna have the coordinated universal time. That makes all the sense. And then the French, I can't do French, sorry, but it's like temps universel coordinate, I don't know. But the tuk. So we had the cut and the tuck, and it didn't match. So they chose to not give in to each other and create UTC, because nobody can be happy. So that's why it's UTC. So it's the universal coordinated time people would think it is, for example, or universal temps coordinate. It kind of works, but it's not what they wanted. And it is the utmost standard for civil time. So when we're talking about these things, the time zones, the offsets, the Zulu, it's UTC and not GMT, UTC. So what are time zones? Well, it's a bag of worms. Sometimes you just think, oh, it's just, you take the Earth and you just do it into cake slices and it's easy and everybody is happy. But reality doesn't make you happy. One of my favorite lines here is here with the cake slide 6. It goes here into the cake slide 7, and here it's on the cake slide 5, and here it's on the cake slide 8. It's very small, and then we have 5 hours and 45 minutes, and 5 hours and 30 minutes, and so on. It's like you can't really do the cake slice of thinking that everything is the same in the line. And that's also just some kind of snapshot, because things can be changing, because a country can choose their time zone and their rules if they want. For example, we have something called the daylight savings. So daylight savings was created during the wars, the big wars, in order to save coal. That's why it's daylight savings. If people go to work 1 hour earlier, they need to go to sleep 1 hour earlier, and thus they don't use coal at home as much when it's dark. So then you save energy. So you also probably heard, because it's sometimes confused with the summer and winter, and the so-called summertime was something invented by some German-speaking part of the war, by some propaganda ministers thinking something like, summer sight. If we call it that, people think, I love summer, so I must love summertime. Ooh, wintertime, bad. And that's still, it was just an effort to save on energy. It has nothing to do with humans. Most humans don't really like it, and some people say that they like it, but usually they think they like it because summer time. So here's a little map. And you can see there's some dark gray areas. These are the smartest people. They have never implemented daylight savings. We have the gray people here, or of the world. They're smart because they have had DST and threw it away like they should have. And then we have the blue and orange, because they're on different parts of the Earth. They have the summer and winter at 2 different times. And it doesn't even help there, because Europe and America, we don't apply the daylight savings at the same time neither. So just because they're blue, it doesn't mean they're in sync. And famously, if I remember correctly, in UK, they need to have a parliamentary meeting every year before they actually apply the summertime. And it's usually a lot of swearings in the so-called database that needs to be updated with these things. And this is also just a snapshot. So this was from November 2022. Here's 2024. You can see there's some very good country. very good country there that removed it. They did it. But we also have Egypt, which didn't do well there. They regressed. But still, the best news was March. It's almost hard to see, but in the end here, a part of Chile, not all of Chile, but a part of Chile, were allowed to remove it. So if you have a computer and it's a time zone, and it's not only Chile, but they have 2 different Chile zones at least. That's good. And then we have something strange over here. Let's zoom in. Here's Arizona. So they have some parts that don't have time zone skippings, and they have parts that do have time zone skippings, and they do have parts within the zone that doesn't have it, and parts within the zone that doesn't have it that does have it. Imagine that. And it's just one state in USA. Most of them have one for it, but it's because of indigenous people that want to have their own controlled zones, and they're allowed to do their own rules for their zones. And like I said, Arizona is a bit special. Anyway, and this is things that computers need to do. They need to know. How do they know it? Well, there's a thing called the TZ database, or the Olson database, sometimes it's also called, but TZ database. This is the utmost biggest thing that you use, and it's included usually in your operating system, your programming language, and even third-party libraries. So if you don't keep these 3 things up to date or know what part is going to be used by your computer program, you will get time bugs later, but not today, because they will start changing things. Let's say Europe remove daylight savings. If you don't have these things updated, your program will continue doing daylight savings while the rest of the world had adapted to not doing it. So it's good to keep up to date. And if you're using Python in particular and don't know what to do, there's the TZ data package that's in the, if I remember correctly from yesterday, PyPI. So you can download that and use it in your program and keep that one up to date, and should be good enough. So TZ database tries to have an updated list of all these changes in our civil time that has happened, and even historical ones. And it even lists these strange things called leap seconds, where they try to say that, oh, the Earth doesn't spin quick enough or slow enough, so we need to add a second or remove a second to keep it up to date with how the stars are looking. And if it's not up to date, then, of course, your program will start bugging. And if you start converting between zones and stuff, it will just convert and be wrong. So this is an example for you, for me. I'm from Sweden. So up until 1879, we were 1 hour, 12 minutes, and 12 seconds off. So if you see a date from Sweden before 1879, then you have this offset. And then we invented Swedish time, which is 1 hour and 14 seconds, so it wasn't really accurate, but it's accurate enough, from 1919. We had here a year when we tried to use summertime, and Sweden was smart back then, so they removed it. And then we joined EU, and we had to have it again. So that's why I can see historically why we have it, and I can also calculate for if it's a time in 1970s, I know that I don't apply the daylight savings times during the summer. And sometimes people are like, yeah, I just write the code myself. This is easy. So that's the biggest problem I usually see. As you can see, it's lots of complex stuff. And if you don't know this complex stuff, then now you should also think that, okay, it's not that certain to just write the code yourself and it's easy. So this is usually what happens first. And then people learn about all these things. And then they, of course, know that they have made an error. So I hopefully have let you know that don't just try to write everything yourself when it comes to time, because just let daytime things in Python do it. Usually works much better. Because I have seen people just try to serialize, oh, I just use the fprintf and create the time myself. I don't need no library to make this ISO compliant thing. I just put it in myself. I just do it. And then it stops working later. And we also have things like this. Sorry. So this is not specific enough, but this is something you sometimes see in APIs. It says from date, 1st of January, until date, 30th of March. Does it include that date? Only the one who wrote the API knows. So when does it start? It's kind of easy to guess. At midnight, probably. And when does it stop? Either after that day is done or before that day is done. If it's during that day, then I'm even lost for words. So you need to be more specific if you ever see things like this in your API. So here, I add a time zone, in my case Zulu, and a time. Now it's very clear when it starts and when it stops, because it can't stop after the time or before the time. And if they actually wanted to have the last day in it, they could have modified it and said it like this, because then it's very clear that they wanted to have the 13th. While in this case, if they wanted to have the 30th, who knows? And that's kind of off by one error. You usually get them in some parts of the code, like when you try to do a loop and stuff, but with date times, you always get them, somehow. But we also have something when it comes, okay, so my computer says a time, but how do I know that the computer knows the time? Well, we have something called synchronization. So when my computer says this time, my computer needs to be up to date with the time. And how is the computer's clock updated with the times? Well, there's an NTP protocol which loves atomic clocks. So it starts off by, we have some atomic clocks, which are super precise clocks. They sync down to some master servers, they sync down further down, they sync down further down. When they sync, they try to calculate how much delay it is, and then you try to apply that so that the differences, once you have synced, aren't very marketable. It can be up to a few seconds in some cases, but it's usually very much up to date. So you can usually count them somewhat great, but not great enough to have supercomputers that need to do things around the world at the same time. But that's a different part. Usually don't things have that. Except Google servers, if I'm correct. But yeah, the client asks for the time, they calculate the thing, and then they get something. And after they know the delay, they know what the time is. So what are these magical atomic clocks? Well, they're clocks that are monitoring the time by checking the resonant frequency of an atom. And why do they do that? Well, we have a SI unit called a second, and it's defined by an atom. So when the cesium-133 atom at rest in 0 Kelvin, that does this number, which is 9,192,600,000, I'm not going to read it all, but when it has done its jig, its little dance it's doing, for that amount of time, that defines when a second is. So if the atom would stop forever, then the second would never happen. But because it does the little dance all the time, it defines a second. That's great. And it doesn't care about our planet and how it spins and stuff like that. So the definition of the time here, of course, is not in some kind of magical alignment with how much the world is spinning. So if the world stops spinning, the time will still go, but the day will never end, I guess. Like I said, it's not up to date with the rotational speed and so on. And that's why we get leap seconds. So this atom clock would still tick, 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 but sometimes, because of different reasons, the Earth moves a little bit less or a little bit more in the spin, and then we try to add seconds for some reason. But these are in the TZ database, so you don't have to care too much about them. And what you do probably know about them is that they have created some major bugs, like I think there was once when all the flights couldn't fly for a day or something like that. That's fun. But yeah, so what to use? Well, if you use UTC, you should use it for mostly anything. It's for wall clocks. What is the time here? What is the time now? UT1, I haven't said that before, but that's if you just calculate what time is by looking at the stars and the planets and stuff. So when the sun is at top, then it's 12 UT1. Because that's how we calculated time before, because we didn't have clocks before trains, really. We just looked at, oh, the sun is up, we go to work. Ah, the sun is on top, we go to eat, and stuff like that. And then we have the International Atomic Time, which is measured by the atomic clocks, because it doesn't care about the observed solar time, and it doesn't care about the civil times. But fun fact, UTC is currently like 47. I haven't updated in a year, so maybe it's updated since, but it's a bit behind TAE, because the atomic clocks do a second, every second. They never stop. So, good that we have something we can trust. Well then, there's a special thing called special relativity. So I will try to just explain it quite simply. Everybody's not a master's degree in physics or anything, but time moves differently between different reference frames. What does that mean? Well, if we have a time on Mars and a time here, it can move differently, and it does move differently. Because of different things like, well, what's the speed of Mars? How much is the gravitational field of Mars? So the time on the atom clocks will move differently, for example. And that's the big thing that he came to mind. But the short of it is that when it comes to time, the universe is just giving you the giant middle finger. Well, on Earth, like I said, it's maybe not the real problem, but when you have space travel and stuff like that, it will be a problem. So, just to have it as an example, we have 2 atomic clocks. They're super perfectly made, so they will forever, if they are in the same room, forever stay the same and always tick together. Wow. But that's only the normal conditions and for all eternity. But we take one of the clocks, and we send it out to space, just on a little journey. It goes around the stars and comes back a while later, while these other clocks stays at Earth. So they will be in 2 different reference frames, and when the clock comes back to Earth, they are no longer in sync. They will tick at the exact same rate when they're here, but somehow, once they came here, they're no longer in sync. But for both people who was looking at the clock going in space and staying on Earth, it did tick at the exact same rate it should have. And that's the spooky parts. Well, is there anything that we actually need to care about this spooky part because it's kind of science fiction-ish, some people would say? Well, yeah. We do have GPS. So what is GPS? Most people have used it. There's lots of different satellites going around Earth, and when you have contact with 4 satellites, you can tell where you are and when you are. So, in order to tell your position and your time, you get to know the GPS's position and time. And they have atomic clocks on them to tell the time. But if they are 1 nanosecond wrong, we get 30 centimeters of incorrectness on a map. Well, that doesn't sound much now, does it? But in reality, they actually would, due to relativistic effects, have 38 microseconds a day, which would create 10 kilometers of incorrectness a day, if we would just send them the normal clocks. Because they move and are in motion, they are 7 microseconds slower, but because they're further away from Earth and thus in lesser gravitational field, they will move faster. And just as another thing, the ISS is about 0.009 seconds. So if you would stay there for a year, I guess, then you would save not much time, but it's something. Well, let's get back to Earth and what you actually want to know about. The top tips for programmers. What do I need to do? Well, when it comes to communication and communicating the date times, make sure that you always try to have the UTC offset at least. You can use ISO 8601 if you want, but I would say that you need to keep and put in the time offset, which is not mandatory. Thus, maybe you should just use this one instead, which is basically the same, but the time offset is mandatory, and that makes me happy. So if it looks like this, with a plus or a Z, then I'm pretty happy. And if it doesn't, then nobody's happy. So always try to use something here. So if you ever do UTC datetime, you do now, you provide the TZ with where you are. So datetime UTC or time zone UTC. And never use these ones. So if you use this one or this one. So the first one is just the now without the time zone, creates a naive value, it's not very good. And the other one stands for useless time constructor now. So if you want something useless and you want it now, there's nothing more useless than useless time constructor now. Because it will also create a naive date, but offset is to UTC, and then you start getting very strange bugs. And it's not only me, but they have also updated in Python 3.12 here. Warning, don't use it. Deprecated. Thank you, Python. So the manual is telling you this nowadays. Thank you. Whoever put it into the specification of Python, I want to thank you if you're in the room. So here's just an example of we're using. I have a computer with the Swedish time zone, and I use all of these. Or I try to just add one day. And then on these things that don't have the time zone, you will see that if my computer is set to Swedish time, it's 25 hours long. And if my computer is set to UTC, it's 24 hours long on both of them. While here, when I set it to UTC, it's 24 hours, because that's what UTC should be. And here it's always 25 hours, because that's what happened in the Swedish time zone during this day, because we moved the clock around. So if you want to write tests are very good to have, and coverage. Well, I would say freeze gun is pretty good to have. So what you can do in your test is just to use freeze time, and then you freeze it to some time, and then when you use date time now, it will tell that date instead. So you can actually do tests around different times instead of actually having to create extra functions and mock them instead. And you can also test whichever it is, because everything that uses datetime now will get these things. I usually use PyTest, so I can get the freezer one to just use it in, and use the freezer move too. I have heard some people also say, well, you should use Time Machine. It's so much faster and so much cooler. It's for C, Python, so probably it's faster and cooler. And it's very inspired by freeze gun, so it looks kind of the same. It's just time machine travel, and you get the time machine that does move to instead. Great. I would also say that I recommend linting. So either you use rough or flake8, and you add this flake8 date times. Then you can get nice errors in your code that if you did write the wrong one, you get the error telling you what to do. Here it clearly says, well, you don't have the time zone, add the TZ parameter, here you did something wrong. And then you can have a pre-check of your code every time you code, and every time someone else codes who hasn't been on the talk. So let's do a little query again. What does it mean, and why did I put this here? Anyone know? No? Oh, we're so unclear? You don't know why I put a Z on the screen? Yeah. I want to see hands up for... Yeah, now I wasn't clear about that, sorry. Hands up if you know what it means. Thank you. And hands up if you think you will still encounter time bugs in the future. Basically the whole room. And the last one here. Will you help with fixing time bugs in the future? Thank you. And that's it. Thank you for letting me occupy a bit of your precious time. Thank you.
Thank you, Petter. Yeah, we're ending actually before time. That gives us a lot of time for a Q&A round. So if you have any questions for a speaker, please come to the microphone, which is over there. Oh, so it's not blocking the cameras. And we'll take you. There's one coming up. Seems. Yeah. Right.
Have you heard of the whenever library, which tries to use different types for different times of times, and so it prevents errors of time because there is type checking mechanism?
Yes, I talked to one person in here who I think was a developer of Whenever, and he told me to look at it, and it looks pretty good. So I haven't looked enough to put it in my slides, but maybe next time Whenever will be there as a big example of how you can make things better, because from reading it, it looks like it solves a lot of problems in a common way that they do in other programming languages, like having instance and whatever.
Yeah, thank you for a very nice and exhaustive talk. I have a question. Had you had the pleasure of implementing rounding logic on times?
I haven't used rounding logic too much in times, but I know that there is a lot of problems with it, especially in Python, if I remember correctly.
Yeah,
so I haven't had the pleasure to have the unpleasure of it.
I have an open problem, that's why I'm asking. So basically it's, let's say, a rounding for a multiple of units and you're crossing the DST jump.
I think it skips and doesn't do that at all, right?
Well,
but Whenever, I think, actually does fix it. The library that we talked about before. So maybe look at Whenever, and I think that one doesn't have the bug.
Yeah, so it gets weirder. I'm trying to round to a multiple of units that doesn't go into a full hour.
Okay.
So, basically when you cross the DST jump, you're at a different offset from the origin. So, yeah, anyway, we'll talk.
Yeah, we'll talk.
Hey, and thank you. I want to share a small anecdote and a question. So in our company, we process logs with timestamps and store them in ClickHouse. And in ClickHouse, it's by default epoch time. So, and once during processing, there was an overflow. So ClickHouse wouldn't accept the resulting value. And I looked it up, and it turned out that in Thailand, the year currently is 2,568. So we had just to clump it and avoid the issue, but are there any tools or any similar situations that you had regarding years?
Regarding years, if you're in UTC, then of course you have the normal UTC, of course. And if you translate it to a localization, if I remember correctly, there's two different formatters. One with a big Y, which is the localized version, and then some other letter I don't remember, which is only the UTC version and always the UTC version.
Yeah, thank you.
Hello. I wanted to ask if you have heard about the pendulum, and if so, if you have heard about the pendulum, the library in the Python, and if so, what is your take on it?
I have only read it from Whenever's documentation when I went through it, I think. Okay. I think Pendulum was there, but I haven't looked at it myself, sorry.
Okay. The second question, you mentioned the extension for the flake8, the daytime. Is there any extension for the RAF as well, for the daytime support, for the linting?
I didn't catch your question, actually. You said, should I go some slides behind it?
Yeah, it was right there.
Is it these ones?
No, the linting.
The other thing, here.
No, linting.
Oh, the linting, sorry. Yes. Yeah, the linting.
Yeah, you mentioned the flake8 daytime, the extension.
This is the rule.
Yeah, is there anything for the RAF as well?
Yeah, the rough and flake 8 both can use this DTZ rule.
Okay.
This is actually done in rough.
All right. Okay. Okay. I thought that this is the extension for the flake 8 limiter.
Yeah, this is maybe the extension for flake 8, but if you want to use it in rough, and I wasn't clear enough, sorry, then you use the rule DTZ, and then they have the rules like DTZ 001 and 2 and 3 and 4 and 5.
Okay. Thank you very much. Cheers.
Yeah, thank you.
Thanks a lot for the talk. I have another question regarding serialization and storage of time. So you mentioned, so Unix time is obviously an int. What about standards for storing the time zone information? Are there any standards for that?
Not that I really know of. You can always serialize it into a string and then have a TZ, or whoever implements it, like an int and an offset, an int and a zone and whatever. But what I have seen from most things, there's no standard for it. So, like in Postgres, you can put it in the Postgres and it does its thing, but how it's implemented, I don't know.
Thank you for your talk. I once, not long ago, on like 29th of February, we had like an outage, which nobody expects 29th of February happening. So it was like connected to back in the code, which deal with like durations, right? Like you need not to only know the current date, but like what is happening next, like in a week. So I wanted to ask about that. What is your recommendations also to deal with like durations?
Yeah. So if you need to deal with durations, first you need to have an updated system that the TZ database is up to date, because otherwise if you're trying to calculate future, it's a bit hard. Just in Python, I mostly just used the normal, whatever it's called. It's imported from the time. It's yeah, the interval, was it? What, you say like days and seconds or whatever, the duration of it. And there's also some other ones that do a little bit more, but in Python, I don't know actually anything better. Because usually you have some structs in like Kotlin and whatever, where you like add a week and add a day and so on. And then they implement towards more or less the same. You need to have an updated TZ and they work. And I know the company I have been consulting for, they also had a bug on the 29th of February where the bank didn't work. So
yeah,
it's not uncommon.
Yeah, that's why we kind of needed all hands like on deck on 29th of February. Thank you.
Hey, sorry, me again. So I'd just like to promote the library I'm working on. So it's Apache Arrow. It's like a general purpose array library, and we try to include a lot of temporal logic in there, so you can actually do time rounding, which might be nice for graphing and such. So just thought I would say it here.
So to have it clear again, it was the Arrow library, right?
So it's the Apache Arrow, not the
Apache Arrow.
Apache, yeah. There is also the Arrow time library, but that's different. Yeah.
Okay, Apache Arrow.
Yeah, yeah, it's used for data science.
Yeah.
Yeah, thanks.
Cool, thank you.
Thank you. Just one last question. I hope you have maybe an answer.
Yeah.
Have you heard of the year 2K38 problem?
Year 2K48.
That's obviously something like similar to the year 2000, where
You mean when it's the 32
overflow? Yeah. Is that a problem in Python, or is Python safe for that? It's probably too general to ask.
Yeah, it depends on your architecture, I would think.
I think so, yeah. Thank you. All right, time's up. Give a thank you round again to our speaker, Petter.